Imagine a tiny songbird weighing no more than a few ounces embarking on a journey spanning continents. It flies over vast oceans, dense forests, and towering mountain ranges, guided not by human-made maps but by nature's intricate navigation systems. How does this bird know where to go, when to start its journey, and how to find its way without any modern technology? Welcome to Infinitia Verity, your portal into the wonders of nature and science. In today's episode, we're exploring a mind-boggling question. How do birds know where to migrate without GPS? From ancient migratory routes passed down through generations to the cutting-edge science of quantum biology, we'll uncover how these tiny travelers master their way across the globe. Stick with us as we dive into the mysteries of bird migration. Segment 1. Mapping the Journey: How Birds Navigate. Birds don't just wake up one day and decide to migrate. Their journeys are carefully timed and guided by a combination of biological, environmental, and learned factors. Most migratory birds follow flyways, ancient, well-established routes that have been used for thousands of years. These routes are often geographically defined, passing along coastlines, mountain ranges, or rivers. Scientists have identified several major flyways, including the Atlantic and Pacific routes used by millions of birds annually. The role of landmarks in navigation. Birds use natural landmarks as navigational aids. During the day, they might follow the curves of a river, the outline of a coastline, or the shape of a mountain range. At night, they navigate using the moon and stars, which provide a celestial map. When flying over unfamiliar terrain, birds can adjust their flight based on their mental map of previous journeys. But what happens when they face bad weather or a shift in the landscape? Birds adapt. Research shows that birds use multiple sensory cues simultaneously: vision, magnetic fields, and even smell to stay on course. Human-made landmarks, a new navigational tool. As human development has altered the natural landscape, birds have also learned to use man-made landmarks such as highways, tall buildings, and even entire cities. This adaptability shows how intelligent and flexible bird species are when it comes to navigation. Interesting fact 1. Some seabirds, like the albatross, can navigate the open ocean for thousands of miles without seeing land for weeks at a time. They rely on the wind patterns and the Earth's magnetic field to guide them. Interesting fact 2. Birds like the bar-tailed Godwit fly up to 7,000 miles non-stop from Alaska to New Zealand, demonstrating one of the most incredible endurance feats in the animal kingdom. Segment 2. The magnetic compass: navigating the invisible world. While landmarks play a crucial role in migration, birds possess an extraordinary internal compass, a biological marvel called magnetoreception. The Earth's magnetic field offers birds an invisible highway, helping them align themselves toward their destination. How magnetoreception works. Scientists believe that magnetite, a naturally occurring magnetic mineral found in birds' beaks and brains, helps them sense the Earth's magnetic field. Some birds also have specialized cells in their eyes, allowing them to perceive magnetic fields visually. But how exactly does this magnetic compass work? It turns out that birds' ability to detect magnetic fields is tied to the Cryptochrome protein, which becomes activated by light and helps birds sense the direction of the magnetic field. This incredible adaptation enables birds to travel long distances, even when visual cues are absent. Magnetic maps in birds' brains. Recent studies have shown that migratory birds create a magnetic map of their environment. This map allows them to detect subtle changes in the strength and direction of the magnetic field as they travel across the globe, providing a constant reference point. Interestingly, certain species of birds recalibrate their internal compasses depending on the season. For example, in the northern hemisphere, birds will orient themselves toward the south during the fall and adjust to fly north again in the spring. Interesting fact 3. The European robin is one of the most well-studied birds in terms of magnetoreception. It's been shown that these tiny birds can detect even minute changes in the magnetic field, helping them adjust their course. Interesting fact 4. Pigeons, long known for their homing ability, use a combination of magnetoreception, the sun's position, and olfactory cues to find their way home from hundreds of miles away. Segment 3. Sensing the Earth's signals quantum magnetoreception. You may have heard the term quantum mechanics in discussions of cutting-edge physics, but did you know birds might be using quantum mechanics to navigate? One of the most remarkable discoveries in recent years is that birds may be using quantum magnetoreception, a process that involves quantum-level changes in proteins inside their eyes. The role of cryptochrome in bird navigation. Cryptochrome is a special protein found in the eyes of migratory birds. When exposed to sunlight, cryptochrome forms a pair of molecules that are sensitive to magnetic fields. These molecules react in different ways depending on the bird's alignment with the Earth's magnetic field, potentially allowing birds to see magnetic lines as if they were part of the visible spectrum. This interaction happens at a quantum level, meaning it's influenced by the fundamental physics governing the smallest particles in the universe. Birds using quantum magnetoreception essentially detect changes in their environment that are invisible to humans and most other animals. Interesting fact 5. Quantum biology is a relatively new field, but it has revolutionized how we understand bird migration. Scientists are also investigating whether other animals like bats and fish may use similar mechanisms. Interesting fact 6. Studies have shown that artificial electromagnetic fields like those from cell towers and power lines can disrupt birds' quantum magnetoreception, causing them to become disoriented. Segment 4. Following the Sun and Stars, Celestial Navigation. Birds have an innate ability to navigate by the sun's position during the day and by the stars at night. This ancient form of navigation is known as celestial navigation, and it has been used by birds for millions of years. The sun compass. Birds use the sun as a directional compass, adjusting their flight path based on the sun's position in the sky. However, since the sun moves across the sky throughout the day, birds have evolved a complex understanding of the solar time. They can adjust their angle of flight to compensate for the changing position of the sun as the day progresses. Star navigation, a nighttime guide. For nocturnal migrators, the stars become their primary navigation tool. Birds like the indigo bunting use the North Star Polaris as a fixed point in the sky to maintain their direction during long nighttime flights. In fact, studies have shown that young birds raised in planetariums where the night sky can be simulated learn to associate specific star patterns with the direction they need to travel. Interesting fact 7. Birds learn to navigate using the stars by the time they are only a few weeks old. Experiments have shown that young birds memorize star patterns during their first migration and rely on this knowledge for the rest of their lives. Interesting fact 8. Even in cloudy conditions or when the stars are obscured, birds can use polarized light, which is invisible to humans, to determine their direction. Segment 5. Learning the route. The role of experience. Not all bird navigation is purely instinctual. Many birds learn their migration routes by following experienced members of their species. This social learning is critical for species that travel in large flocks, such as geese and cranes. The first journey, a crucial learning experience. When young birds embark on their first migration, they often fly with their parents or other experienced adults. These mentor birds guide them along the correct route and help them recognize important landmarks and environmental cues. Once a young bird has completed its first migration, it's much more likely to navigate successfully on its own in future years. However, some species, like the black-poll warbler, migrate alone. In these cases, young birds rely heavily on their innate sense of direction, often completing journeys of thousands of miles without guidance. Interesting fact 9. The Arctic tern has the longest migration of any bird, flying from the Arctic to the Antarctic and back again each year, a round trip of up to 25,000 miles. These birds are known to live up to 30 years, meaning they can cover over 700,000 miles in their lifetime. Interesting fact 10. Some birds, like geese, imprint on the specific migration routes they take during their first journey. They will continue to follow these routes for the rest of their lives, even teaching them to future generations. Segment 6. Preparing for the journey, the biological clock. Before birds even take off on their migration, they undergo significant physiological changes that prepare them for the long, often perilous journey ahead. Migration requires extreme endurance, and to meet this challenge, birds begin to stockpile energy by increasing their body fat, sometimes doubling their weight in the weeks leading up to departure. Zugunruhe, the migratory restlessness. Migratory birds also experience a phenomenon called Zugunruhe, a term derived from German meaning migratory restlessness. As the migration season approaches, birds start exhibiting anxious behaviors, becoming more active at night and orienting themselves in the direction they'll soon be flying. Birds' internal biological clocks are also closely aligned with seasonal changes in light, temperature, and food availability. This allows them to know precisely when it's time to migrate, ensuring they leave before food sources become scarce and arrive at their destination when conditions are most favorable. Interesting fact 11. Birds such as Swainson's thrush can increase their body weight by as much as 40 to 50% before migration, transforming themselves into living fuel tanks for the long journey ahead. Interesting fact 12. Research has shown that some birds' hormone levels, particularly corticosterone, spike just before migration, helping them to manage the stress and exertion of long flights. Weather plays a pivotal role in the success of bird migration. Birds are highly attuned to changes in atmospheric conditions, and many time their migrations to take advantage of favorable winds and avoid dangerous weather systems. For example, tailwinds can greatly reduce the energy birds need to expend, while headwinds and storms can force them to land and wait for better conditions. Understanding barometric pressure. Birds can detect changes in barometric pressure, allowing them to sense incoming storms. This sensitivity to atmospheric pressure helps migratory birds avoid dangerous weather like hurricanes or thunderstorms that could put their lives at risk. Some species, like the golden plover, have been observed flying ahead of approaching weather systems, effectively outrunning storms. Migratory birds also use thermals, rising columns of warm air, to help them soar for long distances without flapping their wings. This is especially common among birds like eagles and vultures, which rely on gliding flight to conserve energy during migration. Interesting fact 13. Birds like the Arctic tern, which migrate over both the Atlantic and Pacific Oceans, rely on global wind patterns to help them navigate and conserve energy during their long flights. Interesting fact 14. The timing of migration is so finely tuned to the weather that even a small change in wind patterns can cause thousands of birds to leave an area simultaneously, creating the phenomenon known as a bird fallout, where large numbers of birds suddenly land in an area due to adverse weather. While birds are widely known to use visual landmarks and magnetic fields to navigate, recent studies have uncovered another surprising navigational tool: their sense of smell. Many bird species have highly developed olfactory senses, which they use to create odor maps of their migratory routes. Pigeons, for example, are famous for their homing ability, and it turns out that their sense of smell plays a key role in this remarkable skill. They use odors carried on the wind to create a mental map of their surroundings. Once they've identified a familiar scent, they can use it to orient themselves and find their way home, even if they're released hundreds of miles away. Recent research suggests that other migratory birds, including seabirds like petrels and albatrosses, use olfactory cues to help them navigate over the open ocean, where visual landmarks are absent. These birds can detect chemical signatures in the air, such as the scent of phytoplankton, to help them find their way. Experiments have shown that when pigeons' sense of smell is blocked, they struggle to navigate accurately even if other senses like sight and magnetoreception remain intact. Birds like the European starling use their sense of smell to distinguish between different regions based on environmental odors, which helps them refine their migratory routes. For many migratory birds, the instinct to travel vast distances is encoded in their DNA. Research has shown that migration patterns are genetically inherited, meaning that young birds know when and where to migrate even if they've never made the journey before. This phenomenon, known as innate migratory behavior, is seen in many species that migrate solo rather than in family groups. One of the most astonishing examples of inherited navigation comes from the black-capped warbler, a small songbird that migrates from Europe to Africa. Scientists discovered that black-capped warblers raised in captivity with no exposure to their natural migration route still attempted to fly in the correct direction when released, guided purely by instinct. In some species, migratory behavior is so precise that birds can return to the exact same nesting site year after year, sometimes even to the same tree branch. This accuracy is often driven by a combination of genetic programming and environmental learning. Studies have found that migratory birds inherit not only the instinct to migrate, but also a specific internal clock that tells them when to start their journey. This internal clock is linked to changes in daylight length and temperature. In the case of species like the monarch butterfly, which migrates across generations, the knowledge of migration is genetically passed down, meaning no individual butterfly completes the entire journey, but the species as a whole maintains the migration pattern. In recent years, advances in technology have revolutionized our understanding of bird migration. Scientists now use a variety of tools, from satellite tracking to tiny GPS devices, to follow birds' movements with incredible precision. These technologies have provided us with detailed insights into the routes, stopover sites, and environmental challenges that migratory birds face. Satellite and GPS tracking. Tiny GPS tags can be attached to birds without affecting their ability to fly, allowing researchers to track their movements in real time. This has been particularly useful for studying long-distance migratory birds like the bar-tailed Godwit, which holds the record for the longest non-stop flight of any bird. Satellite tracking has also helped scientists understand how climate change is affecting migration patterns. For example, some species are migrating earlier or later than usual in response to shifting temperatures and changing food availability. The role of citizen science. In addition to high-tech tracking methods, the rise of citizen science has played a huge role in monitoring bird migration. Platforms like eBird, where birdwatchers can log their sightings, have created vast databases that scientists use to track migratory patterns and population changes across the globe. This has allowed researchers to identify important stopover sites and conservation priorities for threatened species. Interesting fact 19. In 2021, researchers used GPS trackers to follow the migration of a single Arctic tern, which flew over 59,000 miles in a single year, traveling from the Arctic to the Antarctic and back. Interesting fact 20. The use of GPS and satellite tracking has helped scientists discover previously unknown migratory routes, including a route used by the Amur falcon that stretches over 10,000 miles from Siberia to South Africa. The story of bird migration is one of the most incredible natural phenomena on Earth. From their use of magnetic fields and the stars to their reliance on innate behaviors and environmental cues, birds have developed an astonishing array of tools to navigate our planet without the help of modern technology. Their journeys remind us of the intricate balance of nature and how much we still have to learn about the world around us. Thank you for joining us today on Infinitia Verity. If you enjoyed this deep dive into the wonders of bird migration, be sure to hit the subscribe button and tap the notification bell so you never miss out on our next exploration of the mysteries of the natural world. Leave a comment below and let us know what you'd like us to explore next. Until then, keep questioning, keep exploring, and stay curious.